You've probably seen this chart in a quarterly review or board deck. Bars on one axis, a line on another, each on its own Y scale. It's the default move when someone asks you to show two metrics on the same time period. And it's one of the most misleading charts in business reporting. I'll show you why, and then I'll show you two alternatives that tell the same story without lying about it. Let's start with the line. This data is quarterly, 6 discrete points, but the chart draws a smooth curve between them. That curve is invented. There's no measurement at halfway between Q3 and Q4. The chart is showing you motion that didn't happen. Now let's look at the bars. They start at 0, which is correct for bars, but the actual story lives between 2,896 and 3,327. The actual values move about 15%, but the chart visually flattens that into a thin band at the top. And then there's the giveaway, a data table underneath the chart. If the chart can't communicate the values without a table, the chart isn't doing its job. Plus, every reader has to remember which series maps to which side. That's cognitive overhead that the chart should be solving, not creating. Dual axis is an easy one-click step in Excel. It's the path of least resistance, and most of us have never seen the alternatives in a side-by-side comparison, so we don't realize we have a choice. That's what I want to fix today. Before we get to the alternatives, there's one more thing worth flagging, the window itself. The original chart shows Q2 2024 through Q3 2025. 6 quarters. Why those 6? The chart reports year-over-year change for every quarter shown, and by definition, that means the prior year's data is already part of the dataset. You can back into the 2023 numbers from any of those year-over-year values. The publisher has the 2023 data. They just chose not to draw it. When I rebuilt these, I expanded the window to fill 2 full calendar years, 2023 through 2025. 2 reasons. First, most people think in calendar years when they look at quarters. A 6-quarter block that runs Q2 to Q3 reads as awkward. Second, 2 full years let you see the actual arc, a downward trend through 2024, a bottom, and a recovery back to roughly where things started. The y-axis is zoomed to the actual range so the viewer can see the actual movement. Each point shows its value directly, no data table needed, and the year-over-year percent change appears just under each marker, so you get the second metric without a second axis. Notice that the first label spells out year-over-year percent, so the reader learns the convention without a legend. Every annotation is doing real work. This explanatory visualization is information dense. It rewards a reader who's willing to spend a few seconds with it. That's the right trade-off for an article or a report. Let's look at the second alternative. Same data again, this time 2 panels sharing one x-axis, units on top, year-over-year percent change on the bottom. Each metric gets its own honest scale. For the year-over-year bar chart, negative quarters render in red. The direction is pre-attentive. Your brain registers it before you read the number. Notice the inline panel tags, units and year-over-year percent instead of rotated axis titles. In a stacked layout, the reader's eye is already moving vertically. Rotated labels would just add a second motion. Horizontal tags read in one beat. This version is faster to skim, and that's the right trade-off for a presentation or a video like this one. I built these 2 visualizations in Plotnine, the Python implementation of ggplot2. The pattern, though, works for any tool, Excel, Tableau, ggplot, whatever. The point is the design, not the library. When you have 2 related metrics, give each one a scale it deserves. Label things directly and stop letting a smooth line pretend it's data, or let a data table do your chart's job. If you like this video, be sure to subscribe to the channel, and if you'd like additional details on working with data and building visualizations, check out my previous videos on this channel and my beginner's guide, Getting Started with Python on Windows 11. Links are in the description.